The Innovation Hub is a planned building on campus that will create workshops and collaboration space for prototyping. It will also contain some classrooms. Construction is set to begin in the early part of 2021 and will be complete by the spring of 2022. It is part of Mind's focus to develop places on campus for entrepreneurship to thrive. The previous team's senior design project was to create exhibits that show the evolution of innovation. One of those exhibits, which represents the future of engineering, was an autonomous tour robot.
The robot, an idea which was passed along from a previous team, should interact with visitors while avoiding obstacles along a predetermined tour route and then return to its base. It should be able to greet visitors at the door and describe different points of interest as it guides visitors in a tour. The robot is not only intended to serve as a tour guide, but as an exhibit in and of itself, and should therefore be aesthetically pleasing and conform to museum exhibit guidelines, including factors such as ADA compliance, ease of use, and durability. Using information from our meeting with Christine Leahy, our museum consultant, the team came up with a few broad aesthetic concepts for consideration to be reviewed in the design and build process.
Following much research, interviews, and surveys, as a team, we jumped into the dumpster to create an extremely rough approximation of the size and look of our robot that we envision. From there, we were able to break down the problem with our dumpster bot, creating a CAD model and the base of the robot, which much of the year was spent working on. The base of our tour bot needs to contain everything to power, drive, and direct the robot, as well as have room for expansion that future teams can add subsystems such as user interface and obstacle avoidance.
The team's solution to the localization problem is an off-the-shelf product by a company called MarvelMind. This system works similarly to a GPS system, but rather than determining its position by ranging to satellites, it does it by ranging to beacons placed inside the building. The current system configuration consists of a beacon located on the robot, called a hedgehog, and 3 beacons in fixed positions about the building. The hedgehog determines the robot's position to plus or minus 2 centimeters by calculating its range to each fixed beacon using sonic pulses. The localization data is then routed from the hedgehog to the system Arduino as an input to the mobilization system.
Over the last year, our team has come together to create a working prototype of the moving base of the bot, as shown in this video. The robot will determine its position within a defined space and will travel to a predetermined location within that space. With this base, future teams will be able to expand upward to work on a user interface for the robot and to work on making obstacle avoidance for the robot as it moves around in a real-world environment. Thank you for watching our presentation on the Innovation Hub Tour Bot.